people explained our efforts to make the single instance of Redis to work better. 2.2 is something like a monument to how much Redis 2.0 sucked. Because if we, in many datasets, are improving memory footprint 5 or 10 times, obviously there was something wrong in the past version, no? And this is one aspect of our fight to make less better. There is another side that is clusters. Clusters are a more complex topic because I think there is no cluster solution that doesn't suck. So what we can do with our best efforts is to make it as pragmatic as possible. Also, I must admit that the clustering, the NoSQL, key value, horizontal distributed hash tables was very boring because everybody was doing it with good practice, computer science, CAP theorem. So we took the exactly opposite path, trying to do things like, okay, let's try how this will work. No, this doesn't work. So we are, of course, we are always under the same theoretical box. So CAP, we will feel the effects of CAP and other complexity problems that we have in the message busing in every part of our cluster. But our try is to, instead of start from theory, to start with a pragmatic approach. Well, the first of these pragmatic approaches is that the main idea of the whole Redis cluster is that consistency is more interesting than resistance to net splits. Okay, so this is our big idea. Okay, this is how a Redis cluster looks like. There are nodes. Every node is connected to each other node, and there are clients. A few interesting things. These nodes doesn't speak the same protocol that client will use to talk to nodes. It's a different protocol in a different port. It's a binary protocol designed to be fast and small. Because with the protocol we export to our clients, we care a lot that it's simple to implement, it's simple to understand. But in the node-to-node protocol, it's our business. So we can make it as hard as possible to get it as better as possible. And to have a simple protocol played a huge role in the first days of Redis, because we had a long list of clients after 2 weeks, something that's not exactly common. Instead we use a binary protocol. Actually there is an error there, because it's not TCP base port plus 1000, it's 10,000 in the final implementation. Final today implementation. Another very important idea of Redis cluster is that there is no node-to-node proxying. Because I think every schema where there is node-to-node clustering proxying is going to be slow. It's a matter of fact, if there is routing of messages, why clients should not just contact the right node straight, if they can? So we completely abolished, and it was a lot of code, a C code to write to do the proxy. So to obtain a bad effect, we had to write a lot of code. Didn't made sense. Okay, what nodes talk about? That's interesting because they gossip a lot. Okay, our gossip implementation is very easy. Basically, from every second, every node, check the list of other connected nodes and check the ones that have been idle too much time. Oh, it's a lot of time I don't ping C node. Let's ping it. Both ping and pong packets are the same. Basically, the only difference is the type field. And sorry, I have still the post-flu. So how it is the ping and pong packet constructed? It's like a section where I send both in ping and pong my configuration, what is my business. And then there is a gossip section in which I take information I have about random nodes and add this information to inform you of other nodes that possibly you are not talking to in the latest seconds. This is very important to reduce the new number of messages sent in the cluster, and in general to carry more information, because when you send a TCP packet, if you are under the MTU sides, all the data is for free. If you send 1 byte or 500 bytes, it's the same, because the physical frame is the same size. So we try to push as much information as we can in this TCP frame. Also, every node in the ping-pong request exchange the config signature in order to understand for a node if there is a desync in the configuration. Another fundamental idea of Redis cluster is the idea that the key space is split in many different parts. These parts are a fixed number of 4096. So every single node will hold a subset of these hash slots. And when you rehash, to do the resharding, to shard in a different way, you need to move at least an hash slot. You can move half hash slot. It's our atomic unit in the cluster. It's trivial to compute what hash slot a key will belong to. It's just CRC 16 of the key modulo 4096. Okay. Nodes are all connected together. Every node has a TCP connection to every other node. So if there are 10 nodes, every node will have 9 outgoing connections. But not really all the nodes are the same, because there is a kind of node that is a master node and a kind of node that is a slave node. Slave can promote to master if master is starting to have problems, of course. This means that our ability to resist to failures of nodes is limited to the number of replicas we have. So in this configuration, up to 2 nodes can go down and nothing wrong will happen. But actually we can get much more lucky than this, and just all the replicas will go down, or in general at least 1 node for every hash slot will survive, and the cluster will stay up. But the strict guarantee here is that 2 nodes can go down without problems. This design that seems like random, actually there are very important ideas that support this design. The first of our ideas is that to create a key value distributed hash table is a much simpler business if you have just key value that is a string. We have complex data types. So, for instance, if we take, like other databases are doing, the same list in 2 different nodes, updated simultaneously, and there is a net split, when there is the merge again, we have to understand how to merge this list that's composed of these different push and pop. This problem was very hard, and as you can know, there is no real way to do the merging without help from the application. If it's a trivial value, you can say, okay, let's take the younger of these values. If it's a list, you can reason like this. So you needed very complex application level merging. So we skipped completely the problem, and just a single node is the master node for a single key. Then there are the slaves. The slaves don't accept right. So we avoided to resist to net splits because the gain is huge. It's a consistent cluster, not eventually consistent. And in the case of Redis, it was just actually almost the only sane solution because our big data types. And another important point is that nodes do just the minimal work they can do. Every other work is performed using a command line tool that's called Redis trib. Using Redis trib, you can set up new cluster, we will see. But the nodes will just do the minimal work needed. Okay, so if there is no proxying, how this is going to work from the point of view of the client? Because we avoided to put too much complexity up to the client. Let's start with a dummy client, a client that is very minimal support. Let's think that I will release Redis Cluster tomorrow. In a week, what kind of client we can implement? We can implement dummy clients. Dummy client is very easy. It takes a list of nodes and will issue the request against a random node. It will say get foo, and the node, if foo belongs to an hash slot that's not up to this node, it will reply no, moved into 8, that's the hash slot of the key I'm requesting, and the IP address and port of the node that is responsible for this key. Okay? So the client will simply reconnect to the other node and ask again. If in the middle of this process there is a change in the net cluster layout, simply the next proxy will reply again, no, I am no longer the right one, moved in blah, and it will reconnect again. Smart clients will do things in a very different way. To start, they will try to take persistent connections with the nodes. At startup, they will ask cluster hints, that is, give me the configuration as it is now. When they get the moved message, they will update the in-memory table they are taking. So a smart client will, most of the time, directly address the right node. And this should already sound in your mind as horizontally scalable, completely horizontally scalable, because every node is connected to every node, every client to every node. Okay, it's up to the client how much persistent connections it will try to take. But anyway, it will directly address the right node, so the performance and latency will be the one of the single Redis instance that we know already. Okay, this is just what I said. Okay, the interesting part. So let's add a server. What happens if I add a new server to this cluster? It's very easy. See, Redis trib, I will type something like Redis trib add node, and then reshard a few keys in this new node. So Redis trib we analyze, and we'll pick hash slot 7 to move as first hash slot. It will just connect to C.